Now we're going to use a different technique for graphing quadratic equations. The procedure for graphing quadratic equations by finding the x and y intercepts and the vertex point are as follows. Step 1. We find the y-intercept by letting x equal 0. Step 2. We're going to find the x-intercept by letting y equal 0. We'll use the quadratic formula to solve for x. In step 3, we are going to use the formula minus b over 2a to find the exact vertex point. That means we substitute the x value back into the equation to find the corresponding y value, because this formula will only tell us the x value. So once we know that x value, we can substitute it back into the quadratic equation to find the corresponding y value. And finally, with step 4, we'll plot the ordered pairs that we generated in the other steps. That is the x-intercepts, the y-intercept, and the vertex point, and we should be able to draw the parabola based on those important points. So in this example, f of x equals 3x squared plus 2x minus 8. The first thing we're going to calculate is the y-intercept. That means we're letting x equal 0. So we're looking for f of 0. Any x in this function is substituted with 0. So you can see the first and the second terms will be eliminated, leaving us negative 8. So we just generated the ordered pair 0, negative 8. To find the x-intercepts, we need to use the quadratic formula, and this is where the entire function is set equal to 0. So 0 would equal 3x squared plus 2x minus 8. So this is where we need to find a, b, and c. A is 3, b is positive 2, c is negative 8. Substituting those values into the quadratic formula, our minus b means minus 2, plus or minus square root of b squared means 2 squared, minus 4 times a times c, all divided by 2 times a. So that's 2 times 3. To simplify, negative times 2 would be negative 2 plus or minus terms under the radical. Quantity of 2 squared would be 4, and our factors, negative 4 times 3 times negative 8. So we have negative times positive times negative. That would make a positive, so we're going to add something to 4. And 4 times 3 makes 12, and 12 times negative 8 would make 96. Our denominator, 2 times 3, is 6. So let's simplify what's under this radical. 4 plus 96 would make 100. Now that's a nice number to have under the radical because 100 is the perfect square of 10. So that's going to simplify as 10. So our x is going to equal negative 2 plus or minus 10 divided by 6. So one solution would be negative 2 minus 10 divided by 6, and the other solution would be negative 2 plus 10 divided by 6. So if we simplify these, we'd have negative 12 over 6. Negative 12 over 6 is negative 2. And the other solution, negative 2 plus 10, gives us 8. 8 and 6 are both divisible by 2, leaving us 4/3. So we have two x-intercepts. Negative 2, 0 is one ordered pair. And with 4/3, that's 1 1/3. We'll need to know that when it comes time to plot it, but for right now we could write it as 4/3, 0. We need to find the vertex point now, and we're using x equals minus b over 2a to do that. So that means x is negative times b. Well, we found b already up here, so that would be negative times 2 divided by 2 times a. A was positive 3. So it looks like negative 2 over 6, and always reduce these fractions if possible. So that's negative 1/3. Remember, that's just the x value for the ordered pair describing the vertex point. So this means we need to substitute this fraction for x back into the original quadratic equation. So I'm going to continue over here. With our function, we're looking for f of minus 1/3. So we're starting with 3 multiplied by our minus 1/3 squared plus 2 times minus 1/3 minus 8. Make sure you do the squaring first. So 3 will be multiplied by the fraction of 1/9, and then we'll have minus 2/3 minus 8. Multiplying by 3, our first fraction now becomes 3/9 minus 2/3 minus 8. So we'll need to work with these fractions here. The only way we can add and subtract with fractions is if we have a common denominator. So we could reduce 3/9, that's the same as 1/3. 1/3 minus 2/3, we could do that much, and that's minus 1/3. So we have minus 1/3 take away 8. So we need to figure out how many thirds we have with 8. Remember, 8 is the same as 8 over 1. So if I have 8 over 1, how could I build that up to make a denominator of thirds? 1 times 3 would make 3 for the denominator. So I have to build up the numerator by exactly that same factor. 8 times 3 would be 24. Do you agree that 24 thirds is the same as 8? So going back to my fractions, I have minus 1/3 minus 24 thirds. So that's the same as minus 25 thirds. So I'm going to write my y value is minus 25 thirds. When I put the ordered pair together, I'm going to have minus 1/3 for the x value and minus 25 thirds for the y value. Now we're ready to plot all of the ordered pairs that we generated. We should label our axes as x and f of x. Now looking ahead at some of the ordered pairs that we have to plot, it might be difficult to see where negative 1/3 is, so you can create your own scale for x. We could say that each line is worth 1/3. So if I count 3 lines over, that could be positive 1. So I'd have 1/3, 2/3, 3/3. Going 3 lines over, that would be 2. I could do the same going to the left. So negative 1/3, negative 2/3, negative 3/3. That will help us to make the graphing a little bit easier to see. But the f of x axis, I'm just going to count by ones. So now I'm going to go back and find the ordered pairs to plot now that we have our scale. Our y-intercept is 0, negative 8. There's 0, negative 8. We have 2 different x-intercepts. One of them is negative 2, 0. So there's negative 2, 0. The other one is 4/3, 0. So remember, 4/3 was 1 and 1/3. So it's easy to plot now that our scale is counting by thirds. And finally, we have the vertex point to plot. Negative 1/3 is the x value, negative 25 thirds is the y value. So we need to know how much negative 25 thirds relates to in terms of maybe a mixed number. That would be easier to plot. So it looks like negative 8 and 1/3. So if I go negative 1/3 for x value, I'm going down negative 8 and 1/3. So that was just a little bit lower than our y-intercept. So we're ready to connect our ordered pairs and see this parabola. Don't forget to put the arrows. Your parabola should be rounded at this vertex point. It should not be pointy. So do try to round it. It's a lot easier with a pencil. With example 4, we have f of x equals x squared plus 6x plus 1. We have the proper order. The first thing we're going to look for is the y-intercept, and we find that by letting the x value equal 0. That means 0 squared plus 6 times 0 plus 1. So the first two terms eliminate, leaving us positive 1. So the ordered pair is 0, 1. Next, we'll look for the x-intercept, and we'll need to use the quadratic formula here. We'll find the values of a, b, and c. A is positive 1, b is positive 6, and c is also positive 1. So x is going to equal negative times b plus or minus square root of that quantity of b squared minus 4 times a times c, all divided by 2 times a. So that's 2 times 1. X now is equal to negative times 6, or negative 6, plus or minus what's under the radical. The quantity of 6 squared would be 36, and our three factors are negative 4 times 1 times 1. Only one of these is negative, so I will be subtracting. 4 times 1 is 4. The denominator, 2 times 1, makes 2. Simplifying under the radical, we have 36 minus 4, so that would make 32. It is a positive number, so we will have two x-intercepts. But we need to break down 32, probably with our factor ladder, to see if we have a perfect square or not. Division of 2 gives me 16. Division of 2, we get 8. Division of 2, we have 4. Division of 2, we have 2. Divide by 2 again to get 1. So we have identical pairs to make 4, another identical pair to make 4, and then we have 2 by itself. So this pair of 4s will make 16. Square root 16 and square root 2. So square root 16, square root 2, and we notice square root of 16 is exactly 4. So 4 square roots of 2 is how the square root of 32 will simplify. Our x values then are negative 6 plus or minus 4 square roots of 2, and everything is divided by 2. So we can break apart this negative 6 and the plus minus portion with 2, so that will help us to do some reducing, because 6 halves is really 3 and 4 halves is 2. So let's see if that's helpful. X is now equal to negative 3 plus or minus 2 square roots of 2. So that looks a little bit easier to work with. So what we need to know is how much is the square root of 2. Otherwise, we won't know where to plot these x-intercepts. Use your square root function on your calculator to find the square root of 2 and multiply that by 2. And you'll have approximately 2.8. So x will equal negative 3 plus or minus about 2.8. So one solution is going to be negative 3 minus 2.8, and the other would be negative 3 plus 2.8. So when we subtract, we're going to have negative 5.8. And when we add, we're going to end up with negative 0.2. So as x-intercepts, these are going to be ordered pairs. Finally, we need to find the vertex point, and we are running out of room for the vertex point. So with the vertex, x equals minus b over 2a. Looking at our b value, we have negative 6 divided by 2 times 1. So the x value for the vertex point is negative 6 halves, so that's negative 3. This tells us to evaluate our function using an x value of -3. So going back to our function, we're looking for f of -3. So the quantity of -3 squared plus 6 times -3 plus 1. So we're going to end up with 9 minus 18 plus 1. -9 plus 1 equals -8. So the vertex point is going to have a y value of -8. So the ordered pair, -3, -8, is our vertex point. And we can plot our ordered pairs now. So first I want to label the axes. We've got x and f of x. And since we don't have any fractions to worry about this time, I'm just going to count by ones for our scale. Our first ordered pair was the x-intercept at 0, 1. Our x-intercepts, our first ordered pair was the y-intercept of 0, 1. One x-intercept is -5.80, so that's almost to 6. And then we have another negative value to plot, -0.2, so that's really close to 0. So you notice those 2 points are very close. And to finish this, we need to plot the vertex point, which was -3, -8. And now we're ready to connect our ordered pairs, and at that vertex point, we should try to make this nice and rounded. Don't forget to put the arrows on your parabola. Another common term dealing with parabolas that you'll hear about is the axis of symmetry. And the axis of symmetry is simply a straight line that perfectly cuts your parabola in half. And that line is going to go through your vertex point. So we could imagine a line going right through our vertex point. That cuts the parabola exactly in half, and it is a vertical line in this case, and that vertical line has an x value of -3. And notice that is exactly the same x value that was in the vertex point.